Oh, how are we gonna? I feel like this is so cool.
It's live.
It's a little bit weird. Oh, I'm on. Yeah. Hey, what's up, JC? Precal 12. We are section 2.1 to 2.4. Hopefully, you're having a good day. We are going to. This is after school, so you're not watching this live if it's at night. But we are going to get started with some review stuff. So we're going to go through some questions and address the questions as we go, and we'll go from there. All right. So let's start. We're going to do first one. What number? Number 6. Okay. We are going to use the calculator on this one. The 3 ones before I get to number 6, before I get started here. The 3 ones that are like big calculator ones are numbers 1, which I think I did in every class, 6, and 8. The toughest one I think is 8. Okay, so just a heads up on that. Is it on 7 on y'all's? Gotcha. This is number 7 on y'all's. So number 6 says the John Deere company has found that the revenue from sales from heavy-duty tractors is a function of the unit price P. Okay, so P is unit price that's charged. The revenue is represented as the function RP. What unit price will be associated with the revenue of $200,000? $100. Okay, so the question is what is the unit price when the revenue is what is listed? So how can we execute this?
Plug in $200,000, $100 in for the RP.
Perfect. We're just literally plugging it in.
Mm-hmm.
And I think there was one on number 1 that was very similar to this one. I think this one's a little bit tougher, but same idea. And so we go here. So the question is what is P, right?
Mm-hmm.
Trying to solve for P. So let's get this set equal to 0, because anytime we solve for P, we want to make sure it's equal to 0. So we're going to say 0 is equal to negative 1/2 P squared plus 1900 P minus 200,100. Okay? So in solving for P, we're going to plug this equation into our calculator and simply come up with where it crosses at our x-intercepts, okay? Now, as I was talking today in I think every class, I said the toughest part of this is being able to see the window, like try to find the window of the actual problem on your calculator. I'm just going to plug this in, 1900x minus 200,100. Okay, and I'm going to switch screens here so you can see me at home as well. Right now you can't. Let's see if you can see this calculator. Oh, there I am. Let's see, there we are. Perfect. Okay, so I'm going to graph this by plugging this in and graphing it out. Now, it may look kind of weird. Maybe yours looks similar to mine. I always try to start with Zoom standard. Just in case you started there, I'll start the same spot to where you could kind of go to the Zoom standard on this side. The second thing I do is always go to Zoom fit, okay? Because sometimes, again, I can kind of see it or at least see what's going on. So I'm going to go to Zoom fit here, see if that does anything. And that does absolutely nothing on that. So if when in doubt, I always go to like zoom in or out. For me, I probably would go zoom out here and try to get it more on the top. Let's see if we can get it close to this over here. And it might not. And I just kind of work with it a little bit. There's no science to this. And like what we're trying to do, you'll see that this still is at the, yeah, it's way up there. And you'll see it. I feel like I'm getting further away. You see how this right here is 48.7 and negative like 100 or negative 106,000. That's really, really skewed, if that makes sense, because the X is like smushed together and the Y is really spread. So I want to go to, I can always go to my window too to be able to adjust that. So you see the Y, how it's really weird down here. For my X, I can make this like, maybe I'll say it's negative 100. And down below, I'm going to make this a very, very large number. So we'll do like 100,000. Let's just see what happens here. And you can kind of see where it's at. You see it kind of hit twice right there. Y'all see that? So it's really a parabola, which makes sense because it was a negative p squared, right? Negative 1/2 p squared.
Yeah.
To where it will be a parabola that goes downward, right? And should hit twice, or could hit twice, I should say. So this looks weird here. Let's try to zoom in on that. Let's just see what we can get here. Zoom in over on this section. All right. Is this making sense?
Can we just keep doing, instead of the window thing, because that thing, like, the window thing confuses me because I never know what number to do specifically.
Yeah.
And then when I see it like that, that gives me like no help.
Sure.
So can I just keep zooming out until I get to that spot, or will that take me literally forever? Like,
you can do that. Did you see, the one thing I would just say is that I use the window as my last resort, just like you do, because it does become a little weird. I would just say be cognizant of the X and the Y. If the X is like 20 and the Y is like 100,000, right? Which is where I was at. You may want to go into X, and just so that we're talking, like, I might expand X a little bit, possibly.
okay. So how do you know which numbers to do for that window?
For this window here, for me, I didn't, when I went to my graph, I just saw that the graph wasn't really showing me a whole lot. So you can have an option. If you don't want to, you can actually say, you know what, I'm not even going to go to my window. I'm going to go and just start over by going zoom standard and just keep zooming
That's
out.
what I did, and I got this. And I
that's
feel like
much
that
better.
looks like really easy to read. So
That's
I may
much
just try
better.
to do that. It may take me a little bit longer, but I think.
So did you go to zoom? I'm going to do what Alex did, y'all. What I did was
Keep zooming
still
out.
there, but what Alex did, which I kind of like here, is she just kept. Did you zoom out from 0, 0?
Yeah. Well, I just kept going because you know how I gave that line, so I just kept going to the like right corner, kind of, or that middle where you see that line.
Perfect.
It just kept going up and up and over and up. Like you could kind of see it. On yours, you don't really see the line, but
Yeah, I see what you're
and
saying.
then zoom in that last one on that maximum of the parabola.
Gotcha.
To get
So you just
closer.
kept zooming out. Is that
Yeah.
right?
I don't know. Mine looked different than yours. Like I don't know, because I think you started with that window, so that may throw you off. But
That might. You might. Be
actually,
right.
I think you're right. Yeah. So maybe change the window back to normal and then go.
Gotcha. This is kind of where I was originally.
Yeah, this is what happened. You did that too, and you did the window, and it threw us off.
I think it did, and really, to be honest, and this is where people get frustrated. I think is where for this actually, I would still be okay with doing this. The frustrating thing is like each calculator as you go about it, depending on how you zoom in or how you zoom out or how your window is, it could adjust what the graph looks like.
Yeah.
Biggest thing is actually just doing it yourself, right? But this graph right here, what I have, is sufficient to find what we're looking for, okay? Because as we look at this, there is a parabola that goes up, hits once, and then hits a second time, okay? So remember, what are we solving for with this? We're trying to find the zeros, right? And in fact, let me zoom in. I'm going to zoom in on this just a little bit more so I could see what's going on here. But we see that it hits once and then it hits twice, right? So we can go to second. I'm sorry, second trace.
Your line is like blue. It's kind of hard to see.
Is it hard to see? I could change the color. Let me change the color here.
So I want to zoom fit on here, and then you're gonna go zoom
There you are.
out.
Red, would that be better?
You're gonna go like up here and try to keep zooming out until you get closer.
Oh
to
no,
it.
no, no. I'm talking about like on our calculator. It's just like black.
There you are.
Yeah.
Is that better?
No, like I'm talking about.
Oh, on yours. Yeah, I got you.
So yeah, just keep zooming out until you get over here, and then so the uprighter corner. See how I did zoom fit?
Fit first.
Yeah.
I got you.
Do zoom fit first, and then you go up, and then after like 3 or 4 times, you'll start to see the parabola form.
Oh, yeah.
And then just one more time, I think. Oh wait.
Oh, look.
Hey, there we go.
Literally went zoom fit, and there it is.
Yep.
So, well, y'all, you could do it this way. You could also do it the way beforehand. Either of these options are fine. Again, zoom fit's a good option. Sometimes it does throw you off where what Alex was saying, we do start with zoom fit, and then we kind of keep zooming out. And what we're trying to do is trying to see where does it cross the x-axis, right? So now what we can do is go to second trace, and we're going to find 2 zeros here. To find the first, we're going to go left bound, which is lower than that x-intercept. We'll go right bound, which is up above that x-intercept. And then we're going to guess somewhere in between. And when we do, we get the first zero is 108.4. Okay. We can do a second one by going to second zero.
Just leave it there. Okay. Okay, I'm sorry. So we're doing,
Cool.
We're finding the zeros.
Correct. And the first one on this left side was 108.4. Okay.
Okay.
Now, the reason why I wanted to show that to you is because we really want the one on the right side, and I'll show you why in a second. On the right side, you're going to go left bound. Oh, yeah. Let me backtrack. So we're going to go second trace to 0, right?
Okay.
And then that's where we go left bound. And then we go right bound, which is below. And then we guess somewhere in the middle. And when we do, we get, if you get this, 1e to the -7th, that's 0. It's like, it's
really?
small number. If that ever happens, that's what sometimes your calculator is estimating that, but it's 0. And so the 0 is 3,691.6. So the question is this the correct answer, or is it 106.7 the correct answer?
How would you get 106.7?
That was the first one over here. This first x-intercept here was that side. You don't have to solve for that. But the question is which is the correct answer? Well, this is where we go back to our context and say, okay, we're talking about tractors here, right? Would a tractor be $106 or $3,691.60? This would probably be more, right? Rather than $106.
Yeah.
Someone last year actually defended themselves, which I was really respected. And they said, well, it didn't say if it was a toy tractor or not, but we're going to assume that it's a real tractor, and we're going to say that it's 3,691.59 there. Okay. Cool.
So that's our answer.
That would be our answer. All right, let's go back to, I know it took a while. I think that was good, though, just going through how to use the calculator. It's a big part of tomorrow, I know. Do we have another one at all?
Number 7, which is 8.
Cool. Yeah, number 7 is another one that we want to look at in terms of, here's the equation. Now, the question that it asked us was, first off, what is the domain? We're going to look at that in a second. And then on my version, it says, what is the value for x, where v of x is the maximum? And again, v stands for our volume in terms of centimeters, right? So volume is v of x, okay? And x is stands for, if you remember the picture I showed the other day of the amount that like you can cut out in a corner, and as you cut out more, it affects the volume, and as you cut out less, it affects the volume as well. So the question is based on this equation, what is the maximum volume, and what is the x value that would produce the maximum volume? So that really sounds kind of crazy. Really, let's find the maximum is really what they're saying. So let's find it here by plugging it into our equation. Did I do this in either of y'all's classes?
Yes, you did it in our class.
Cool. I know I did it in one. Okay, so we're going to go to, I think this one might be the tougher of the ones here. Okay, let's go to literally just plugging it in. So we're going to go x times 23 minus 2x. Is that right?
Mm-hmm.
Cool. And then that's squared.
Close parentheses squared.
Rocking. Okay, so we're going to try Alex's method. I'm going to just keep doing your method because I like it.
Okay.
Let's go to Zoom Fit. Let's try. Hopefully it won't let us down here. There you are. Okay, so this right here really tells me nothing other than the fact that we have our end behavior of falling to the left and rising to the right. But the key in this is what it's asking is what is the maximum. Do you see a maximum in here? I don't. Like where it hits the top and then drops, right? I don't. But what we can do is zoom around 0, 0 and be able to see, well, is this actually happening? Is there something going on here? So let's go to zoom in. Let's go zoom in here. If you find it, let me know. I think this would be good. See, we'll keep zooming in. And I think, Let's see. It's probably not doing it still, is it? Okay, it's kind of a straight line. So we kind of hit a little bit of a brick wall. That's okay. In terms of Alex's method, though, yeah, no, that's not that we're wrong. We just need to kind of tweak it. So my second option would be I would start at zoom standard.
That's what I just did.
Can't you just do
Cool.
zoom in? This is what mine.
Yeah, I'm looking at Nikki's right now, and hers looks good. Yeah, yours looks absolutely great.
So then go back to where like you did Alex's method, and then after that, zoom in on like the straight line.
That's kind of what I did. Yeah.
Well, I just put zoom fit in, and this is kind of what it did in terms of when it does zoom fit, it bases it on where you're currently at, right? So sometimes it's good, and sometimes you might. I mean, I'm still, even as a math teacher, I'm still trying to work on it. My big thing is I know what I'm trying to find, right? And I've got to mess with that zoom feature, zooming in, zooming out, zoom fit, zoom standard, to be able to get it to where I need to go. The good news is tomorrow is that I'm not trying to trick you. These problems are very similar to what I'm looking for tomorrow, okay? And there's 3 of them, and they're going to be very similar to where I'm at. So I'm going to zoom out one more time, see if I can get one more picture. I think that went worse. Let me see if I can zoom in. There you are. That makes it much better. It does. If you have someone who has a calculator like this, who has the colored ones, just the one above y'all, I would do that. If one of you can get, actually, do y'all have separate classes?
Yeah.
If y'all have separate classes, you can borrow mine tomorrow.
Okay. I have one. I just need to charge it. I've been using this. I should probably use it.
Yeah, so you can use you can use mine tomorrow. That's fine.
Okay.
So what do we know about this equation in terms of volume? We talked about it in class a little bit. What can we eliminate?
Negative and infinity.
Good. Anything that goes to infinity, which is this right side, we can get rid of, because a volume can't go to infinity, right? Because our volume is something that's set in stone. We also can eliminate anything that is below the x-axis, because remember, v of x is representative of y. So we can eliminate that. So the only value that we can definitively say that this could be the domain of my function that represents my volume is from 0 to a value on this right side. Well, to find that value, we can find what our x-intercept is, right? So we can go to second, trace, go down to 0, and we want to go left bound and right bound. And let's see if this will get it. Hopefully this will take it here. And it didn't because of the fact that it did what? Here's a good example. Why did it not give me my x-intercept? It goes through 0, right? But if it bounces, the way that it thinks about the x-intercept, it has to have a sign change. So it has to go above the x-axis and below. Okay?
Oh,
does that make sense?
Yeah.
But if you remember in class, I think, Alex, we did it together, right?
Yes,
in terms of, let me get this up. We talked about how on this, when I looked at the zeros for this one, this 23 minus x, minus 2x. Here's a question right here. What are the zeros based upon this equation?
0 for the x,
0.
and then 23 over 2, which is 11.5.
Good. 23 over 2, or it's actually exact, 11.5, right?
Mm-hmm.
And that's when I set both of those equal to 0. What's the multiplicity of 0? You don't have to write this, but this is just for hopefully help. 1, which means it goes through, right? What's the multiplicity of 11.5? 2, which means it bounces, which is what our graph showed us, right? So our domain is between what?
0
and 11.
to 11.5.
Good. Can it equal 11.5 or 0?
No.
No, but it's up to those values, right? Good. So that's our domain. Now our maximum becomes much easier because right here, now we just simply go to the equation and we just do the second trace, right?
Yeah.
Cool beans, yeah. Second trace, then where do we go? Maximum. Cool. We'll go left bound. We'll go right bound. And we'll guess it. And there you are. So let's talk about what it's saying here. What's the maximum volume?
901.3 centimeters cubed.
Correct. Nice. And then the X that you cut from the corner to maximize the volume, if I said, hey, what can I do to maximize this volume? You would literally say, oh, I have to cut out 3.83 centimeters. Okay. Cool?
Yep.
All right.
The maximum is 901.
Correct. And then the X value that maximizes the volume would be 3.83.
Okay.
Good. How do y'all feel on those? Y'all feel
Good.
better?
I like that we went through those in class. That really helped because I would have had no clue if I just like.
Yeah. I'm hoping that, I'll be honest, the two I just went through are the two that, the three calculator ones I'm most concerned with, just because they're, it just takes a little effort to get it on your calculator. That's why I would save those for last, which I think are the first three on there. I think they're literally the first three, which was brilliant on my part, I know, but I would just save that maybe for last. All right. Any other questions?
Can we go through? Let's see here. Like number 9 or number 14, it's put this formula in vertex form, then identify the intercepts in the vertex.
Vertex, perfect. First thing is this. These are ones that you're going to have to show work for. Okay. The x-intercepts, I'll talk through that real quick. The vertex, to find the vertex, you're going to have to show work. And to put it in vertex form, you're going to have to show work. But to find the x-intercepts on this one, you can do two things, okay? You can, first of all, you can't factor. But if you could factor and set it equal, I would do that.
Yeah.
But you can't. So when you can't factor, okay, can't factor this, what are two things you can do to find the x-intercepts?
Plug it into the calculator.
Perfect. You can graph it. And
Or the quadrant.
there you are, quadratic formula, right? So either of those two options are good. I would just say be careful. If I say show work on there, I would go with this, okay? But if I never said anything on that, if it does not fall in that section, then I would use this, okay? Because of this problem, number 9, even if I said show work on this, the fact that you're gonna about ready to show work on the vertex form makes it okay for you to graph it. Here's the deal. Because of the fact that that's kind of vague on my part, it is appropriate to ask me, hey, coach, could I just show this on my calculator?
Yeah.
And then give you the x-intercepts.
Okay. So
and I'll tell you, this is one we need work for. Or,
and you could even check it. Like you could do the quadratic and then check it on your calculator and do both to make sure you got it right.
Yeah, that's a really good point.
Yeah.
Very good point. You could do the quadratic and then check graphically. Always. That's good. So I'm going to do this for the x-intercepts. I'm going to say that you can check it with a graphing calculator. If I did that, would that make the x-intercepts a little easier to solve on this one?
I think so, yeah.
Cool.
I was going to start, with putting it in vertex form.
Yeah, let's do that, and then we can always come back to the x-intercept.
Yeah.
Okay, so vertex form, this is something we need to know. If you're watching this podcast, I said you need to know it for the test, and I think I accidentally put it on the test. So there you go, right there. If you're not watching the podcast, then I'm sorry. Sorry about that. All right, so with that being said, we're trying to find h comma k is the goal. This is also in standard form, what's been given to us. And in order to find the h comma k of this, we can do what?
Negative b over 2a.
There you are.
3 over 2.
Good. So it'd be 3 minus negative 3 over 2 times. Oh, hold up. B is 9, right?
It's negative 9 over negative 6, but
Negative 9 over 2 times negative 3. Sorry about that. And that would then be what?
3 over 2.
3 over 2, right? Yeah, because it'd be 9 over 6. It'd be 3 over 2. Okay, so once we get the x value, we do what to find the y value?
Oh, plug 3 over 2 in for our x.
Good. So each place x exists, we're going to say, okay, we're going to plug 3/2 in, or 1.5. I saw a lot of people use their calculator today in another class when we did this. That's absolutely okay. As long as I plug in and show that I'm, in fact, plugging 1.5 in for it. And then just do PEMDAS sometimes. I mean, all the time. Your calculator doesn't understand PEMDAS with the equations you plug in. So make sure that you do 1.5 squared, then multiply and go. Okay. What'd y'all get for that?
I'm still working.
Cool. Also, while we're finishing this, we're wrapping up, one thing too I want to put on the podcast is number 11. Just be leery on number 11. This is for the podcast viewers of filling in the x values there. So x squared plus 0x plus 4 is what we're dividing by. So just divide that there. I got negative 1/4.
That's what I got.
Is that what we got?
Yeah, thank you.
Cool. You want me to check that one real quick? You got it there? Okay, cool. All right, so negative 1/4 is what we found here. And I would double, triple check that because it's easy to mess stuff like that up. And then also showing work is key as well. So now as we wrap this up, we can now put it into our vertex form because we've got our vertex of HK. And simply we just plug it in. So what we see up here is we plug in H and K. And so we have y equals a parentheses x minus 3/2 minus 1/4 right there. And we plug it in. But there's one thing we've got to solve for. What is it? A. Yeah, do you know how we find that?
Yeah, you plug in 0 for y, right? Oh wait, or no?
If we plug 0 in for
oh no,
y,
is this where? Oh shoot, I don't know. Is this where you make a table?
you don't even have to do that. The a, remember this is ax squared plus bx plus c. The a is negative 3.
Oh, I forgot.
And the a down here is negative 3. So that's my equation right there, vertex one. So there's a couple ways you could do the x-intercepts. You could plug 0 in for y, add 1/4 divided by negative 3. That'd be intense.
And then what would be the x-intercepts?
The x-intercepts, I would do quadratic formula.
Can you write that
Yeah, absolutely. That I
down?
counted how to attack it,
Um,
like the negative b plus or minus
yes.
1. So x equals negative b plus or minus the square root b squared minus 4ac all over 2a, just like that. So x equals negative 9, right? Plus or minus the square root. What's b squared?
81.
Yep, that's exactly right. Minus 4a is negative 3, c is negative 7, and then all over 2 times negative 3. Sorry, I know this is all over the place. This is my x-intercepts down here. Sorry about that. So this negative 4 times negative 3 times negative 7 is negative 84 is what I've got. So 81 minus 84 would be negative 3, right?
Yeah.
So we have negative 9 plus or minus the square root of negative 3 all over negative 6. Because this negative is on the inside, we can make it positive and just put an I on the outside. And I could leave it like that. If I wanted to simplify, people mess this up all the time for some reason. I'd put the negative 6 underneath both.
Mm-hmm.
So I would say negative 9 over negative 6, which is 3/2, plus or minus I squared of 3 all over negative 6. And you can do that as well.
Can't you find like?
That's our x-intercept.
Which means, here's a question. What does this mean in terms of my x-intercepts?
Centers 2.
Ooh, okay. It's incorrect, but why is it incorrect? If this I wasn't there, would you be correct?
Because it's
Imaginary. So this graph, what it does, and you can actually look on your graphing calculator, it actually does that. It actually misses it all together. So that's why they're imaginary. Gotcha. That's cool. That's a good question. It's a really good question, Ernie. Good. Okay, we got that. That looks like a mess. Cool. Let's go to the next one. Y'all have another question there?
14's the same one, so we can skip that since we just learned.
But there's just like a version.
Which one, number 13 on mine?
Yes.
Perfect. So this one, what I would do, make sure 100% that we're going. Okay. What I would do is the same exact thing in finding the vertex. First thing though is I would multiply -2/7 across. So I would say f of x equals -2/7 x squared minus, what is that, 12/7?
Mm-hmm.
X. And then what would that -2/7 times -21 be?
42/7, which is 6.
Great, good.
Plus 6.
That's exactly right. So now we've got our equation for our vertex. What is our a going to be?
-2/7.
Good. So we can put that right in there, and we know we're just trying to fill in the h and the k. That's the goal. So in doing the h and k, we can find this by doing -b/2a. And so we've got this will be fun.
Oh,
-b/2a. What's b?
-12/7.
Good. And what is 2 times a is -2/7, right?
Mm-hmm.
Okay. Actually not as bad as you think. Because on the top, we turn that into 12/7, right?
Mm-hmm.
And on the bottom, we turn this into 4/7. -4/7, you're right. And then we flip it to then get multiplied by 7/4. And then 4 goes into 12 3 times, right? So I got -3. -3 is my h. This is -3. Okay. Now I would come back over here. Just makes it a little easier because it doesn't have the fraction in it. To multiply, to put it into like -3 in. I think it just might be easier.
Yeah.
So we could just do -3 before we multiply by -2/7. So we say -3 squared. So 6 times -3 minus 21. So -3 squared is 9. 6 times -3 is -18 minus 21. And when I do that, what would I get?
Oh wait, hold on. -30, and then you multiply that times -2/7.
Good. And you could do this as a decimal. I'm okay. Well, I technically I could just keep this as, this is -30/1. We just make it 60/7.
Mm-hmm.
And then I just come, boom, 60/7's here. That goes in as my k. And my h is minus -3, so +3. That's where I'm at. Now, to make this easier for me algebraically, what I might do is I've already showed how I did the -3. Remember, it's all about showing work. What I could do is then go into my calculator, plug in this original, and just check to make sure that that indeed is my maximum value. So there's ways to kind of around being able to really check to say, because this is such a weird value, does that match up to what is on my calculator? Because your calculator you can use all of tomorrow. The big thing is just making sure you show some work, how you got here, but then you can always check and say, is that really my answer? Because I recognize there are a couple steps that may be easy to kind of get messed up on if you're not careful. Okay? That's actually a good one, Nathan. That was good.
So then what's the intercept?
Say that again.
Does it ask for
I think it just said in vertex form. There.
Intercept. Then identify the intercepts.
It says intercepts too.
Yeah.
That's really mean of me. I would do it on a calculator. It doesn't say it on this one. I would say do it on a calculator because I could do this. I could do it. Definitely is not. It's not factorable. It's two numbers that multiply that equal -21, but when added to get equal to 6, I can't think of any. 3 and 7.
Yeah.
There's none. So you can cross that
So
off.
you can plug, you're saying you can plug this original equation into your calculator and then find your zeros to find your.
I would do that, and that's why tomorrow, before the test, let me double and triple check the test that because I was tweaking it this weekend. I'll check and make sure, and I'll try to be very clear on, oh yeah, this is one that maybe you could do. And be very clear before you take the test so you're not trying to guess what's going on there.
Okay.
I think that'll be good. I'm going to make a note to myself, dude. Cool. In fact, while you're thinking of the next question, I'll
So cross off the intercepts.
yeah, just cross off the intercepts for that one. I'm good with that. I had this in my backpack because I just printed them off earlier.
So interesting.
What the heck? Let's do it. Ooh, look, the first three are the calculator problems. What do you know? This is a good one right here. Okay, check this one out. It is on your. It was not on the review, but it is in your homework. Okay. You remember the one where I gave you the vertex and the point, and I said use the vertex and the point to find the quadratic in vertex form,
Oh yeah.
where you plug the point in
You
H
just
and
plug
K.
X, Y, and then H and K and solve for A, and then yeah.
That's it. That's it.
I can't say it.
Rational zero test is important.
Okay.
Okay.
Wait, so are you gonna give this like a really hard one where we have to like there's like 15 different kind of zero that could possibly be it. Like
Say that one more time.
the one that you gave, like the 25 over negative 4. It's not gonna be like that.
There's one that's going to be like that where you just list the possible
Okay.
zeros.
But it's
The
not-
one that I have as the challenge question,
Is to actually write out all the zeros, right?
the one that I have, yes. It's I want to be, so it's lengthy, but the first number, the lead coefficient is 1.
Okay.
Cool. So that means that if you did P over Q,
Oh,
that means
yeah.
it would be over plus or minus 1.
Okay.
You got me?
Oh, sweet. So
And
that's
then
not
you'll use different ones to solve. Save the challenge one to last.
Okay.
Is that's a good one.
bad. Do we get the full hour and a half, right?
You do.
Okay, good.
You do. The only one I would say look at is transformations. And like if you had a value on the outside, what does that mean?
Shrink or stretch.
Correct. So
I know.
there is, okay, so let me two things. Number one, x-intercepts. There is one where you have to find the x-intercepts. On that one, you'll need to know how to do the quadratic formula because it's definitely not like this one. Cool? All right, so, and there's only one of them. So that whole checking, there's one of them, but you'll do the quadratic formula and show. Okay? The other one is, and this is for those of you who are watching this as well. Y'all are here, y'all are working hard, so I'll give it to you. The one that will be similar to the one on the test, if I had one, and I'm choosing a hard one on purpose, okay? Okay, choosing a hard one on purpose just so that you can kind of prepare for it. I'm not saying all of them are like this. There's like one like this, okay? What is the graph of this right here? What is the picture going to look like?
It's gonna look like an S.
Good, yeah, it's
Okay.
going to look like this, right?
Yeah.
I would just kind of mentally note that so you know where it's going. Where's the middle? Normally at 0, 0, now where is it?
1. Wait, 1.
Okay, 1/2 would be like
Shrink
a
or
stretch or shrink. It's actually going to push it down, so it'd be a shrink.
It's gonna shift down
So
to
that's
Good, down 2, and then this goes
left 1.
left 1. Good. So this is the horizontal. This is my vertical. So it's going to go left 1, down 2. Okay? So now just to kind of make sure that we have the graph where it needs to go, I would just plot just a point or 2. Okay? So I might just plot like 1,
How do you do that?
like to plot a point. I just pick maybe 0. Let's just do 0 just to make it easy. 0, we plug in for x. 0 plus 1 is cubit we get,
1.
times 1/2 is
0.5.
0.5 minus 2 is,
1.7.
yeah, so this is 0.5, right? And I probably could do it like show work, right? 0.5 minus 2. And if you had your calculator, it would be negative 1.5, okay? So 0 would be negative 1.5 right there.
That's why I meant with like the half.
Gotcha.
Go up.
Gotcha. So now what we have is this is going to go this way, right? Okay. And I'll probably do one more point over here. And then if it goes this way, that means on the left, it's going to go left 1 and down 1/2, right? It's going to go like this way. If I want to be more accurate, especially on one like this, I'll probably extend it just a little bit further by doing something like 2. Or let's do 1. I'm sorry. Let's do 1. 1 plus 1 is 2. 2 cubed is times 1/2 is
4.
minus 2 is
2.
good. So 1, 2 would be, so we'll do 1, 2. So this actually should go like this. So it would go right 2, up 4, right? So this would go left 2 and down 1, 2, 3, 4. Somewhere around that area, right?
Yeah.
That's sufficient. That's good. That's all you need to do. Now, mine is glorious, right? Not really, but that's sufficient. You plotted it. You knew where the transformations were. So how would I describe that? I would say this is a horizontal shift left 1, vertical shift down 2, and then I would say that this would be a shrink.
What's the shrink and stretch rules again? If it's a fraction, it shrinks, and if it's bigger than a fraction, it stretches, right?
Correct. If I remember the stretch, the shrink is easy for me. If I remember the higher the number, the more tension on the rubber band I'm pulling, the thinner it gets. So we would say that's a stretch. I'm stretching it further.
Yeah, the higher the number stretch, and then the lower the number it shrinks, because it's like, okay.
That's exactly right. So it's going to flatten out more.
And so on the test, how would you ask that question? Would you say graph the transformation and then?
I said one of them, graph it, and some of the other ones I said just describe it.
Okay.
So we did both of them
Okay.
for the hardest one that could be on the test. So if you understood this one and understood how I graphed it, you will be fine for that part. But those two, this one and then the one on the point and vertex, those are the two that are not on the review, that are on the test. Those are the only two that I saw that are not on the test, or that are not on the review.
Okay.
Wait.
Cool. So like if I gave you a point that said that it was 0, 3, right? And the vertex was 3, 4.
So
right?
that's not on the review, but it's going to be on the test.
Correct.
Okay.
But there was one on the homework. Similar.
You
Very
just
similar.
plug the point in and then your vertex and solve for A.
Then
So
good.
HK.
You know how to go to vertex from vertex form to standard form?
Oh,
Wait, don't you do X
Right there.
minus 3? Oh,
So if I said change that to standard form, right?
yeah.
We would take x plus 3,
Oh, wait. Yeah.
square it, right? To get x squared plus 6x plus 9. I know I'm going quick.
oh yeah, just distribute it out. Okay. Yeah,
Distribute negative 4 in, right? So you
Mhm.
get negative 4x squared minus 24x minus 36, and then I add 5 to make this negative 31.
Cool.
Cool.
Okay, and then can you just go over number 13? I know, because it's just because
Yeah.
I like have trouble with
Which
that.
13 again was it?
It's like
Describe the
finding-
end behavior of the following function.
Yeah, absolutely. That one's
I
not
don't
there
think
for some
that's-
reason. Is it this
that-
one?
No, number 9 on yours. Wait, no, it's
Wait, no, it's number 10 on your.
number 10 on mine? Cool.
it's on 30.
So there's two different things that are going on, right?
Yes.
First off, we have the, let's talk about the degree, okay? What's the degree of this?
6.
Good. And Nikki, what's the lead coefficient?
Negative 3.
Good, and we just need to know that it's negative, right? With an even degree and the lead coefficient is being negative, what is my end behavior?
Okay, wait. So like, because it's opposite, isn't it?
It's opposite, good.
So then,
Think of, here's how I think of it. Remember an even degree? We think of a parabola as like x squared, right? So both will rise or fall.
Yeah.
And so because of that, what will happen?
rise, right, fall.
It's actually, okay, so if it's even, they will rise and fall together, right? Rise left, rise right.
No
so
matter
then
what.
it's
So
gonna
if it's
ri-
even, it's
fall
either gonna
left,
rise or
fall
fall. And
That's what I
Oh,
meant to
that's-
say.
okay.
Fall right, fall left.
That's it.
That's what I
whoops.
Fall left, fall right. Cool.
Okay.
If it's odd, I go positive because of positive slope.
Whoa.
Cool. Let me go again. So if I said this, we're good. All right, just did a bit basic one, okay? Degrees,
3.
good, and the Lee coefficient, good, okay? So it's degree of 3, so they're going to do opposites, right?
Yes.
And because it's negative, if it's negative, think of like,
So like odds, opposites.
yeah,
Okay, cool.
yeah, that's exactly right. Oh, I like that.
Yep.
That's why I have y'all. I like it. And we know that it's negative, so that means that we,
Oh,
Rise
okay.
left, fall right.
because it's a negative slope.
Okay. But if that was a positive one, positive G coefficient, would it go the other way?
I'm going uphill. From left to right.
Okay, that's pretty common sense. I was like looking at it like as like a formula, just looking at it on the board and not even thinking about it. So I just was like, how am I supposed to remember this? But
Yeah, I probably should have done that. That actually came to me earlier today. I think I've taught it this way before. I just forgot.
yeah.
But yeah, it'd be positive. Cool beans. Alex, you got another one?
Let's see here. Maybe number 15.
Absolutely. Is this the right one that I have up here?
Let's see here. Yes, it is.
Gotcha. Let's do it.
This is pretty much just like algebra, right? Just like solving it out.
Correct.
Okay.
So
So let's just work through it.
Yeah, that's cool. So negative I times 1 minus 3i, let's distribute that first. Okay? And just to get rid of it, so we've got only 1 on that left side. And what would we get when we distribute negative I?
Negative I plus I squared.
Plus 3i squared. Good, yeah. And Alex, what would this turn into if I were to simplify it?
Negative I minus 3.
Nice. Now, what about the right side? Can we simplify the 4 minus square root of negative 36?
We can pull out an I.
Cool. So we would be left with
4I minus 36.
Wait, 4 minus I.
close, yeah. So
Oh, you can't combine. Yeah, 4 minus I root 36, correct?
good. And we can say, okay, so we can say this is 4 minus I root 36.
Uh-huh.
And what is the square root of 36?
6.
Good.
Oh,
We
I
can
thought
say-
yeah, I didn't realize they didn't simplify.
Yeah, all right. Good. Now this makes it much more doable. I mean, other than what they gave you, this looks a lot better. So now we can then just simply distribute, right?
Mhm.
What do we get?
4I plus 6I squared
Nice.
minus 12
Mm-hmm.
plus 18I,
Good.
which is 14I,
Mm-hmm.
minus 18,
Good. How'd you get negative 18?
because the 6I squared turns into negative 6.
Yeah, that's really negative 6, right? Good. And really to write it, it's the real number first, and then,
Oh, really?
yeah, technically, I don't even know why that's the case, to be honest. There's things,
Wait.
I don't know why they did that. Alex, you want me to back up?
Yeah, can you back up? I think I got ahead of myself and just didn't think it through. But what did you? Can you go through it again? So you got
Down.
so
You get negative 4i, right? Let me do this in a different color. Maybe this will help. You got
oh,
negative
I forgot to write that down. Okay, that makes sense. Okay, so so 4. Wait, how did you get negative 4? Oh, I didn't realize that I in front was negative. Okay, so negative 4i, and then plus 6, right?
plus 6i squared, right?
Which turns
Plus 6i squared, which is negative 6.
Correct.
Okay. And then negative 12, and then plus 18i, and then that's 14i, and then negative 18. So you write it negative 18 plus 4i, 14i.
Correct. That's
Sorry.
exactly right. You rock that.
Sweet. Okay.
Good. Number 16, it's pretty much the same type of thing. The one thing I will tell you is you want to square a number 16 Or did you have one like this?
We don't have one like that.
You don't? Well, this might be just an extra one for you.
Okay.
I don't remember if I saw one quite like this on the test, but if you're watching the podcast right now, what I would do is be sure to square 3 minus 2i, and then square 4 plus 3i, and then be sure that negative gets distributed to the whole right side.
Okay.
Does that make sense?
Yeah, that's doable.
And then we'll just combine and add like terms is all we're looking for.
Okay, can we work on the long division again?
Yeah.
I remember we did it, and I feel like I got it. I just don't. I always get stuck on like one spot.
Absolutely. So yeah, x to the fourth, right? Minus 5x to the third. Is that the same one?
Yes.
8x squared minus 20x plus 16. We're going to divide that by x squared plus 4. Okay. What would you do first on this one, Alex?
Hold on 1 second. Okay. So I would multiply what times x squared gives me x to the fourth.
Mm-hmm.
So that would be x squared, and then I'm going to put that over my x squared, line it up.
Great.
So then that gives me x to the fourth,
Mm-hmm.
and then I do that with the 4, right?
Correct. I would add that 0x in here.
Oh my goodness, that's why I always forget to do that. Okay, wait.
That would be the only thing, and I think one is very similar to this tomorrow. Like
Okay.
one's like where you have to
Yeah.
add it either inside or outside.
Okay, so this is what I get confused on. So what do I like? Can you explain this next step, like the 0x, like?
Yeah, so we just simply distribute this to all 3 parts, right?
Oh.
So x squared times 0x is
0.
good, 0x to the third. And then x
Oh.
squared and 4 get me.
4x squared.
Good.
Oh, I get it now. Okay. And then you have to change your signs.
Correct. Good.
So then our x to the fourths are going to cancel.
Nice.
And then, let's see here. So we have 5x cubed. Negative
Mm-hmm.
5x cubed. And then plus 4x squared.
Nice.
And then do we bring down anything? We bring down our negative 20x.
Good.
20x. And then do we bring down that 16 also or no?
You can, but I would just leave it because you have 3 here. You just need 3 to match up on this
Okay.
green side here.
So now what do I do? This way.
Just start the process over again. So what times x squared gets me the negative 5x to the third? You just keep doing that.
Okay. Negative 5x.
Mm-hmm.
Okay.
Good.
And then you multiply that by that down there. So negative 5x cubed,
Nice.
and then minus 20x cubed or squared. Wait, this is where I'm getting sorry.
Cool. So same thing. We go 1, but we got to go to the 0x2, right? And then the 4.
Oh goodness. Wait, how did you get it? Oh, I get it now. Sorry. Okay.
You're good.
This is confusing. I'm sorry. I'm really bad at this. Okay.
No, it's just it just takes practice. Right? You're good.
Okay, so then I have negative 5x. Wait.
Did you get negative 5x on top? Isn't that what you had said here?
Yeah.
And then now negative 5x times x squared is negative 5x to the third, right?
Yeah, I
You
have
got
that.
What's negative 5x times 0x?
0.
There you are. Yeah.
0.
0x to x to the
The
second.
0x throws me off. I don't know, like, if it's okay. So plus 0x squared. Okay, and then negative 20x.
There you are.
Okay,
Yeah.
there we go. And then change signs.
Mhm.
So then, so all we have left, because our 20x's cancel, and then our negative 5x cubes cancel. So all we have left is 4x squared.
Great.
Okay. And so now we bring down that 16. That
Good.
plus 16. And then.
Could I make a recommendation? Let's keep that 0x here.
Oh goodness.
The only reason why is you could really do without it, and that's okay. I just like to keep all x's here. And since there's a 16, now if there was no 16, I would just keep it as 4x squared. But since that's there, just so you got
That's gonna kill me. I can't remember to do that. My goodness. Okay.
If you left it, you could still get there.
Okay.
You can still get there. So then what do we do now?
It's what times x squared gives me 4x squared.
Correct.
So
Good.
4, so plus 4 up here.
Nice.
So, and then, okay, so then 4 times x squared, 4x squared.
Nice.
And then 0x.
Nice.
And then plus 16.
Great.
But then we're going to change our signs.
Great.
So
Good.
then we have negative 4x, negative 0x, or negative 4x squared, and then negative 0x, and then negative 16, so everything cancels.
Give me a remainder of
0.
Good.
Wow, that's so long. Okay.
You rock that. What does that mean about x squared plus 4?
It's factorable.
It's a factor of the whole
Yeah.
polynomial, right?
Yeah.
And it's actually a factor of, and this times this would equal what's inside.
Cool.
Okay. You got that. It just takes a little practice, you know?
Yeah, I always forget that you have to like use everything and keep going back to that first divisor. That's confusing.
That is a tough one.
Okay. Let's do, and for number 11, the 5 minus 2i over 3 plus 3i, that you just multiply by your conjugate and then distribute out, right?
Correct.
Okay.
That's right.
And then,
And if your I did not get out once I distributed on the bottom, so you did something wrong, right?
yeah.
So that's exactly right.
Okay, that's good to remember. Let's see if there's any other ones. Let's do number 2. Find 2 quadratic functions, one that opens up and one that opens down.
You'll like this one.
Okay.
You'll like this one.
Okay.
Because this one's not too bad because you got f of x is equal to this, right? Remember if I said earlier, if I said x plus 1,
Yeah.
x minus 2 squared, and I said, what are the zeros? You would tell me.
-1, +2 with a multiplicity of 2 for the 2.
Exactly, right? And then 1 for
Yeah.
-1. Okay, good. With this one, it's just backwards by saying, here's the x-intercepts, put it in a quadratic form.
Okay.
So -4, 0 turns into
4.
x plus 4. Good. And the +5 turns into?
X minus 5.
Good. Now let's distribute this.
Okay. So that's x squared minus 5x plus 4x minus 20.
Mm-hmm. You're right. Yep, that's exactly right.
Okay. And then, so that's x squared minus x minus 20.
Good. That's 1 right there.
Okay.
To make the -1, what can I do with this equation?
Just put a negative.
Literally distribute a negative to all 3 parts.
Okay, but we have to distribute that. So this first one B opens up. And, okay. And then you would have -x squared plus x plus 20 would open down.
Correct. But it would still have the same x-intercepts, right?
Mm-hmm.
Still have the same x-intercepts.
Okay, that's not bad. Okay, and then for number 3, the using synthetic division, does using a fraction, that kind of throws me off. I know it shouldn't, but oh wait, yeah, because you would put +5 halves in the box, correct?
Correct.
So how would you do that? How would you recommend doing that? Just doing full head-on fractions, or do you think turning it into a decimal and then changing it back?
You could do either way. You could always, since you're using a calculator, utilize it. I'll show you. I think you can still do it with a fraction. So if we bring down that 2, if I did 2 times 5 halves, right? 2/1 times 5 halves. What does that turn into? Yeah. Then I can combine to get me.
Okay. -12.
Good.
And then, so -12 times 5 equals -60 divided by 2 is -30.
Good.
And then is 26.
Good.
And then is that 60?
6 here. Yeah, I'm sorry.
No, you're good.
So negative 65.
And then so 26 times 5. 65.
Good.
So we have a remainder of 0.
Which tells me that 5/2 is
It's a factor of that.
correct. So it's an x-intercept of that too.
So my answer would be 2x squared minus 12x plus 26.
correct. Good.
Okay, that's not bad at all.
Yeah.
On the test, is it going to be a fraction like that where it's easy to? I mean, I guess that's a dumb question, but you know what I mean.
So. I think that the one that got to me was one like this when we talked about like tough ones that just they require a little bit more. I won't say that all of them will work out neat and clean, but the idea of this is to also not try to trick you, but to just get you to regurgitate and say, oh, I understand, comprehend, and can utilize, the information, Okay. So I would just say show work, and if there's one that you get to that you're like, man, that didn't make any sense, that answer didn't make sense, just go back and do it again. And I usually did that even on tests in high school, is if I got an answer that I was like, that doesn't sound right, put it on the back burner, and then then come back and then just redo it without looking at the answer. Okay. See if you get there.
And then can we do number 5? Unless, do you need to go, or like, are you good to keep working?
I think I could do one more. Is that cool?
Yeah, that's fine. So write a polynomial function, standard form, that has the following conditions.
Cool. Yeah.
So,
what are the factors here?
So our zeros are, I'm going to put an x on the outside, and then x plus 3, and then x minus 2, and then, and 2 with so x minus 2 will be squared.
Good, and you can put 2 or squared, either one of those would be okay.
But it says our degree is 4, so.
This degree still would be 4, because if I multiply it out.
Because there's 4 x's. Okay, that makes sense. And then that's it?
And then it says put it in standard form. So on this one,
I have to distribute it out.
Distribute the x times x plus 3. Get that, right?
So that's x squared.
And then distribute the x minus 2 and x minus 2. Get that?
Okay.
And then distribute the rest of it.
Okay, so that's not bad. All right, perfect. Okay, that's good.
Is there any other ones that you're like, a little?
I think we covered them all.
We hit on all of them.
Yeah, no, we did. Thank you. That's really helpful.
Good.
Perfect.
Just those 2 that were not on the review on that. But this is Coach Jay signing out. Hope you had a fantastic day, and we'll see y'all tomorrow. Bye.